Welcome back, everyone. It is Remote Learning Week 2. Our lesson for today is about oxidation numbers. And before we start our lesson, we will get settled and centered with a mindful minute. So, wherever you are, find a comfy seat. Make sure you're sitting with your head, neck, and spine aligned. And we'll take deep breaths together. I encourage you guys to close your eyes or look down. And together, inhale through your nose, exhale, inhale, deep breath in, and exhale. Inhale, fill your lungs with oxygen, and exhale, pushing the air out. Inhale, and exhale, stress and tension. We're halfway there. Inhale, and exhale, releasing stress and tension. Last one, inhale, and push out stress and tension from your body. Allow your breathing to return to normal. And check in with yourself. How do you feel? What do you notice? Just be mindful of what comes up for you. And when you're ready, you can slowly open your eyes. And welcome back. So today's learning target is I can determine an element's oxidation number. Pause the video now so you can write this down. Last week we learned about redox reactions, which is a shorter way to term reduction and oxidation reactions. Think back, what are some things or processes that use oxidation reduction reactions? So, plants use oxidation reduction during photosynthesis. We use oxidation and reduction when we perform cellular respiration. And your cellular devices use redox reactions when your battery is powering your phone. So, looking back at some of the homework that you guys did, I know that we need a little bit of review on questions like this. So, this will be our do now. Let's take a look at this Regents question. Given the balanced ionic equation representing a reaction, so we got zinc solid plus cobalt aqueous gives us zinc aqueous and cobalt solid. Aqueous is referring to something that is dissolved in a liquid. Which statement describes the electrons involved in this reaction? So it's basically asking us, what are the electrons doing in this reaction? We can see from our options, it's saying either zinc is losing electrons or gaining electrons, and cobalt is either losing electrons or gaining electrons. So let's take a closer look. I see that each of the options starts with the zinc. So I'm going to look at zinc first. So zinc solid, we look at what's happening to it in the reaction, we can just isolate zinc. Zinc is going from a 0 charge to a 2 plus charge. So what's happening here? Is this oxidation or is this reduction? And how do you know? Well, if it's going from 0 to a 2 plus, that means electrons are being lost. And I remember from oil rig that oxidation is losing. So I know zinc solid is losing electrons so that it can get to zinc 2 plus. So which of these can I immediately cross out? I can cross out 3 and 4. Let's look at cobalt and see what cobalt is doing. Cobalt is going from a 2 plus charge to a 0 charge. Remember, it's 0 when there's nothing there. So if it's going from a 2 plus to a 0, the charge is reducing or going down. And I know that reduction means electrons are being gained. So which of these options best fits? It's 1. Yay! Because zinc is losing 2 electrons, we saw that, and CO2 plus is gaining 2 electrons. So let's review this one question that was part of your homework last week. Given the balanced ionic equation representing a reaction, copper solid plus silver aqueous gives us copper aqueous plus silver solid. Ag is silver. During this reaction, electrons are transferred from blank to blank. So we have to look at our equation and figure out which of the elements is losing electrons and which is gaining. So we can do this by looking at one at a time. So let's look at copper first. And then we'll look at silver second. A helpful trick is to isolate your elements like this. So copper solid is starting with a charge of 0, and it's going to a charge of 2 plus. So it is doing what? It's losing electrons. So this is being oxidized. Ag plus is going to Ag0, so that means it is gaining electrons. Reduction is gaining, so this is my reduction, half reaction. So what's actually happening here? Where are electrons going from and where are they going to? Where are they coming from and where are they going to? See what you can cross out, which doesn't make sense. If I know that reduction is gaining electrons, I know electrons are not being transferred from the silver atoms and ions. So it must be one of these. Well, we looked over here and copper solid is losing electrons because it's being oxidized. And we also saw that silver plus is gaining electrons because it's being reduced. So my answer is 1. My tip for answering these types of questions is isolate your half reactions first, just like we did in the beginning and like we did in the previous question. Then you can more clearly see which is being oxidized and which is being reduced, and you can go from there. Okay, moving on. These numbers in the top right, which represent the charge, are also referred to as oxidation numbers or oxidation states. We're going to watch a video about how to determine an element or ion's oxidation number / oxidation state. At this point, I encourage you guys to take notes as you watch the video, and I will pause the video at a certain part where you definitely should write down the notes. Along with this are also check for understanding questions in your Google form.
In this video, we're going to learn how to figure out the oxidation numbers for the different elements in a chemical compound. The oxidation numbers are the numbers that I've written here above each one of the elements. Now, if you want to learn more about what oxidation numbers are or why they're important, check out my video called What Are Oxidation Numbers? In this video, we're going to work through the process of how you figure out what these numbers are. So here are the rules that we're going to use to figure out oxidation numbers. Now, just so you know, every teacher and textbook has their own version of these rules, but they all work in pretty much the same way. So if you learn mine, you'll still get the answer right 100% of the time, even if these are a little bit different from your teacher's. I'm going to talk through a few of these rules right now, and then I'll introduce the rest just as we work through practice problems. The first is this. An element by itself always has an oxidation number of 0. Here's what I mean by that. There are a lot of chemical compounds that have just one element. That element is not combined with any other elements. That's what I'm calling an element by itself. So that's something like Cl2. It doesn't matter how many atoms of that element you have, just as long as it's only that element and none others. So Cl2, an element by itself, oxidation number of 0. Sodium, Na, by itself, 0. S6, just sulfur, nothing else. P4, phosphorus, and nothing else, 0. So that's probably the easiest rule here. It's always 0 for the oxidation state if you have an element by itself with nothing else. The other rule here is about monatomic ions. These are ions that are made of only one atom. So like this. For monatomic ions, their oxidation number is the same as their ion charge. So for K plus here, its oxidation number is going to be plus 1. For N3 minus, it'll have an oxidation number of minus 3. And Mg2 plus here is going to have an oxidation number of plus 2. Now keep this in mind. When we write oxidation numbers, we write the sign first. So plus, minus, and then the number after. This is the opposite of how we write ionic charges. So just keep that in mind. The charge might be 2 plus on magnesium, but the oxidation number is plus 2. Now for the rest of these rules, we usually use more than one together. So I'll just talk about these as we use them in example problems.
Okay, before our friend Tyler continues to talk about these, pause the video, write down these rules in your notes right now. You can write them just like they are here. It's going to be super critical for you to have them written down when it's time to do your check for understandings and when it's time to do the assignment for the week.
Here is our first example. KCl, we want to figure out the oxidation numbers of the elements in this compound. Okay, so let's take a look at our rules here. K, potassium, is in this column in the periodic table. It's in group 1A. So there's this rule that elements in group 1A are always plus 1. So that is potassium's oxidation number. Then we have Cl over here. That is one of the halogens. Halogens, usually minus 1, positive with oxygen. Well, Cl certainly isn't with oxygen here, so we'll give it a minus 1 oxidation number. Now, I want to use this to show you a third rule. That's this rule right here. The sum of oxidation numbers for a neutral compound equals 0. KCl is a neutral compound here. It doesn't have a charge after it. So that means that the sum of these oxidation numbers is going to equal 0. And that's definitely true here. Plus 1 minus 1 equals 0. We'll use this later on when we do other examples, but just keep that in mind. The sum of oxidation numbers for a neutral compound should always equal 0. And
just want to point out that on your chemistry reference table, this is group 17, not 7A. It's in the same position, second from the right, but on your reference table, it says 17.
MgO. Mg is in this column in the periodic table, group 2A, and group 2A elements are always plus 2. So there's that. Oxygen here, we have a rule for oxygen. It is usually minus 2. It is minus 1 in peroxide. H2O2 hydrogen peroxide is the most common peroxide. It's probably the only one you'll ever see. But anyway, this oxygen is definitely not in hydrogen peroxide. So it's fair to say that its oxidation number will be minus 2. Plus 2 for Mg, minus 2 for O, and they add together to make 0 because this is a neutral compound. CO, carbon monoxide. Let's figure this one out. Okay, so C here, there isn't any rule for carbon. So we'll have to figure it out based on what we do know. Okay, so we do know oxygen. Oxygen is usually -2 unless we're in a peroxide, definitely not a peroxide. So we can safely say that oxygen's oxidation number is -2. Now, let's use this other piece of information that we know, and that's the sum of oxidation numbers for a neutral compound should equal 0. So whatever carbon's oxidation number is should add together with oxygen's to make 0. So we can figure out that carbon's oxidation number should be +2. -2 from oxygen gives us 0. NH3. Okay, N, there isn't any information about that. So just like in the last example, we'll have to figure out its oxidation number using what we do know. Here we've got hydrogen. There's a rule for hydrogen. Hydrogen is +1 with nonmetals and -1 with metals. So nitrogen is definitely a nonmetal, which means that in this case, hydrogen is going to have a +1 oxidation number. Okay, but there are 3 hydrogens. Each one of them has a +1. So what we have to do is we have to multiply this +1 times 3 for the 3 hydrogens, and that's going to give us +3. Now, let's keep this rule in mind that the sum of oxidation numbers for a neutral compound should equal 0. NH3 is definitely a neutral compound. We don't see any charge here. So whatever nitrogen's number here is needs to add together with +3 to make 0. So that means that nitrogen here has to be -3. That adds there to get 0. So its oxidation number is -3, hydrogen's is +1. CaC2. So calcium here is in this column, group 2A, so we know that its number is always +2. We don't know what carbon's number is, but we can figure it out. What we do know is that calcium's number plus whatever carbon's number is needs to equal 0 because this is a neutral compound. It doesn't have a charge. That means that the total number on carbon is going to be -2. But there are 2 carbons here. So we have to divide this number between the 2 of them. So we're going to take this and divide it by 2 to get an oxidation number of -1 for each one. +2 for calcium, -1 for carbon. NO2 1-, check this out, it is an ion. So this is going to be a little bit different. In this case, the sum of oxidation numbers for a polyatomic ion equals the ion charge. So let's see how we'll use that here. Nitrogen, we don't know what its oxidation number is going to be, but oxygen here is usually -2. So we have -2 here, but we have 2 oxygens. So we're going to do -2 times 2 is going to give us -4 altogether. Now, whatever nitrogen's is, when we combine it with -4, we need to get not 0, but we need to get -1, because that's what the ion charge of NO2 1- is. So this means that we will have 3 plus 3 plus 3 minus 4 gives us -1, which means that the oxidation number here on nitrogen is going to be +3. HNO3. Okay, let's take a look at the rules. We got hydrogen. Hydrogen here is combined with nonmetals, nitrogen and oxygen. So that means that its oxidation number is going to be +1. Oxygen over here is going to be -2, but we have 3 oxygens. So we got to take this -2 times 3 to get -6. Okay, so now we have +1 from the hydrogen plus whatever nitrogen is, -6 has got to give us 0 because this is a neutral compound here. So that means that in this case, nitrogen's oxidation number will be +5. 1 plus 5 minus 6 equals 0. Now I'm going to start talking about some more challenging examples that use some rules here that are a little less common. ZN.
All right, those challenge questions or these challenge examples I will post at the within the lesson. However, it is optional. You can do that if you want to challenge yourself. Okay. So, recall in the video, he talks about polyatomic ions, and these are ions with many atoms, and they can be found on table E in your reference table. So, we're going to do 3 examples together. Our first one is ammonium. How do we know this is a polyatomic ion? There are 2 atoms in this ion, and we know it's an ion because it has a charge of +1. So how did we determine the oxidation numbers of the nitrogen and of the hydrogen? So I'm going to write it out. NH4. Oops. This is a lot trickier than it looks. Trying to draw without a pen. Okay. So looking back at your rules that you should have written down in your notes. If you did not write it down in your notes, pause this video, go back and write them down. Otherwise, you may be confused. So looking at our rules, hydrogen we know is a +1 charge. But there are 4 of them. So we need to multiply that by 4, and that gives us +4. Now this +4 added to whatever nitrogen is, going to leave a blank there, must equal +1 because the overall charge of our polyatomic ion is +1. So what must the charge of nitrogen be to give us a +1? Using algebra, I know that -3 will give me a +1. -3 plus 4 equals +1. Now, how do we know we're doing this right? If you look at your reference table and you look at nitrogen, your oxidation numbers are written on the corner, on the right corner of the element symbol. And I see that -3 is one of the oxidation numbers, so I know I'm doing it correctly. Let's try another one. I actually wanted to point out on your reference table that your selected oxidation states are shown in the top right-hand corner. Okay, so now you know what those top right corner numbers represent. Those are the oxidation states, also called oxidation numbers. Okay, let's do another example. Cyanide. Cyanide is a very toxic substance. It causes your cells to stop accepting oxygen, and we know that our cells need oxygen to survive. And it was used in concentration camps during the Holocaust. It was a very toxic substance. So let's find out what are the oxidation numbers in cyanide. Now, carbon and nitrogen both have multiple oxidation numbers. We look at our reference table, we see that there are several options. So how do I know which ones to use? Well, we can start by looking at the charge. We know that whatever the oxidation numbers are here, they have to equal what? They have to equal -1. So let's look at our options here. What 2 number combinations would give us a -1? Well, if I look, I see that carbon has a -4 as the first oxidation number. That means it's the oxidation state that it's most likely going to take. So if we try -4 here, then I know that I need a +3 for the nitrogen. And sure enough, there's a +3 oxidation state for nitrogen. Okay, let's try one more. Okay, hydrogen carbonate. Hydrogen carbonate can be found in the ocean when carbon from the atmosphere goes into the ocean. If you guys have heard the term carbon sink, That's when the oceans absorb carbon dioxide from our atmosphere. So the oceans actually serve a really important role in storing carbon dioxide. And carbon dioxide takes the form of hydrogen carbonate during the process. So when it goes into the ocean, it doesn't just stay as carbon dioxide, it actually changes forms. So this is really important in ocean chemistry and pH of water. So let's take a look. HCO3 minus. Okay, so we can look at our rules and we know right away, we can determine right away two of these elements by using the rules. Can you guess which ones? Hydrogen always has a +1 unless it's with a nonmetal, and unless it's with a metal, and then oxygen is a -2. Now, there are 3 oxygens, so we have to do what? We have to multiply this -2 by 3. So that gives us -6. And hydrogen remains as a +1. Now all I need to solve for is my carbon. So I'm going to leave a blank there for carbon. And all of these added together need to equal a what? They need to equal -1 because this ion, it's a polyatomic ion, has a -1 charge. So 1 plus what -6 gives us a -1. What do you think? This has to be a -4. Oh, +4. So this gives us a 5 -6. That gives us -1. Now let's check if we're right by looking at our reference table in the oxidation states. And yeah, carbon has a +4 oxidation number. So I know I did it correctly. So let's try this Regents question. State the oxidation number of oxygen in the aqueous product. Remember, aqueous means a solid dissolved in a liquid. So it's denoted by this AQ in parentheses. So there's no oxygen here. So let me keep looking. Okay, here's my compound that I need to look at. So it's 2NaOH. Now this big 2 in the front means that there's 2 of them. So that's just like writing if I were to do 2H2O, that means there's 2 water molecules. So I can actually ignore this 2 for now because I'm just trying to find the oxidation number of the oxygen. So what are our rules? So using my rules, I know that hydrogen is always a +1. I know that sodium, Na, is in group 1. So look at your rules. Sodium has to be a +1. And oxygen, if these are all going to equal 0, because this is a neutral compound, oxygen must be a -2. So that gives me +1, +1, -2, 0. So I know I did it correctly. Okay, if you need more practice, there is a second video that I will post in the assignment, and you can watch this for extra practice. Remember to fill out your questions in the Google form and the check for understandings, and then your week 1 assignment will be due on Tuesday. See you next time.